Hey guys, and welcome back to a new video. This is the third part of the biking weather application. An application that based on some calculations on the weather data tells us which day is the best day for cycling, running, or any other outside activities. In the last videos, we built the clean architecture structure, the domain, and the data layer. And in this video, we are going to work on the presentation layer. And finally, we are going to build the view model of the application together, and we will finish the dependency injection today. So hit the subscribe button, give me a thumbs up, and let's jump in. Let's have a quick review on what we have done in the previous videos. We built the domain layer. We had these two use cases, one interface with a repository, and two, let's say, data classes, because we need them to calculate the data and we need them to receive the data. But inside this data class, we had multiple data classes. From the top, which was the main data class, weather response, till the sub branches of this data class, and at the end we had these two data classes to calculate the score that we need to build the application, and this data class to work on the data of a single day that we are receiving from the API. Here in the data layer, we built the configuration object, the weather API service, and we implemented this repository here. And finally, the dependency injection. We built the module together. We have created and prepared some of these objects and classes, and we made them ready to be injected to the view model, but still we didn't create the view model. Here we have the presentation layer, and we are going to work on it and build the view model inside it. But before we start, let me give you some explanation about what we should do inside the view model. The view model has three main parts. The first part is about the location. We are going to check the permissions, and if it's granted, we are going to take the location, and out of the location, we are going to extract the latitude and longitude, and the first part is done. Then we are going to send the request to API to receive the data. So the latitude and longitude will be sent to this weather repository and the implementation and the API service finally to receive the data about the weather. And this is the second part, and it's going to be done by this use case. And finally, we need to calculate bike riding score through this use case, and this is the third part. The received data is raw data. We need to do some calculations as well, some preparations as well inside the view model, and send the ready data to the calculate bike riding score use case to create the score for us. What's this calculation? I'm going to tell you right now. As in the last video, I showed you the weather API is going to give us the forecast for 5 days and every 3 hours. But the hours that we are giving, we are receiving the forecast or fixed timetable. So midnight, 3 a.m., 6 a.m., 9 a.m., 12 p.m., 3 p.m., and 6 p.m., 9 p.m., and again midnight. There is nothing between these slots. If you calculate, we are going to totally receive 40 items. Each day, 8 items, and totally is going to be 40 items. The received data is in a group. we are going to divide it based on the date to 5 groups. So after that, we know that this data belongs to this day, that data belongs to that day. Then we are going to do a calculation and make average number out of the received data for each day. For example, for day 2, we have 8 items. Each item has its own temperature. We are going to sum all of the temperatures and divide them by 8 to have the average temperature of day 2. And we are going to do for all of the days and all of the factors. As you remember, we had these factors: temperature, wind speed, chance of rain, the weather condition, and the humidity. We are going to do this for all of them. And the final score is going to be passed to the use case to do the calculation for the score. Something else that I want to mention here is like this. If you check the application right now, the today's date is 16th of September. This is day 1, day 2, day 3, day 4, day 5, and day 6. We have 6 days. But we know that API is going to give us like 5 days data. Why it happens? Let me show you. Consider it's 12 p.m. and we are going to send the request to the API. Already from the midnight to 12 p.m. we lost 4 items of the day first. So we are going to receive 4 remaining items here and 4 full days, each day containing 8 items, and the day 6 from the midnight till 12 p.m. also 4 items we are going to receive, and these 4 items still we cannot get it because the API will not give us this. So you can see that we have 4 complete days and 2 half of days, and totally it will be 5 days. That means 40 items. But in our application, the process of making the average and sending it to the use case is going to be done for these 4 items as a complete day, and for these 4 items as well as a complete day. So even if the time is like after 9 p.m. and only 1 item of this day remains, it's going to be considered as a full day. The average of 1 item will be that 1 item. And here in this day we are going to have 7 items, and we are going to extract the average amount out of those 7 items. So I hope it's clear for you. Now let's go to the Android Studio and write the code. Before we build the view model, here in the root package, where is it? Here. Yeah, right click, new, and we are going to create a class, and let's call it weather biking application. We need this application class for our dependency injection. So inside this application class, we are going to write the onCreate function. But before that, we should give the inheritance of application to this class. Then we're going to be able to use the onCreate. The override function onCreate. After the super onCreate, start Koin. And inside of it, we need to pass the context and the modules. In this case, you have only 1 module, but if you have multiple modules, you can add all of them inside this parentheses. That's it for this class. We need to define it in the manifest. Inside the manifest here, we need to have, let me zoom. We need to have tag of name, and it's here, dot weather biking application. This one is unused, we can delete it. Here we need to have some permissions. This one, the first line is required, the second line no. Uses permission, chorus location, and quartz, and find location. That's it. Control Alt L to line up everything, and we are done in the manifest. We don't need anything else here. Let's go to the packaging. Let me close data, dependency injection, domain layer, and here in the presentation layer, right click, new package, and view model. Or any other name that you want. You can call it weather view model or something else. In this case, we have only one view model, but if you want, you can separate them. A view model for receiving data of the weather, or another view model for location strategies, another view model for something else. But it's better to keep it in like a single view model, all of the data. It's better. Okay, now here we have the class view model. As you remember, in the previous videos that we used the view model, we used to give inheritance of view model to this view model class, but now we are using the just like this that the AI is proposing to me. But in this case, we are using the Koin dependency injection, so we are going to give inheritance of the Android view model to this view model class. Import it, and this application is the weather biking app that we have built it right now. So not here, actually here. Yeah, we need all of them. The application, the get weather forecast, and calculate bike riding score use case. We need these two use cases and this. Okay, as I said, we have three parts in the view model. So for these three parts, we need some variables to store the data inside them. Let's create all of the variable together. I'm going to comment a tag for each of groups and make it easier to understand for later that you are going to check the codes in my GitHub repository. So we need a private variable. Let's call it the location. Fuse location client. Let me describe the type. Yes, exactly. And equals to location services, get fuse location provider client, and we are going to pass this application as the context. And later after this, we need to check the permission. So private val underscore location permission granted. equals to mutable state of false. Mutable state of false. This is a private value to check the permission here out of a function that we are going to create together. And later we need a public value to check it from outside of the view model and see if we have the location granted or not. So we need a value, let's call it location permission granted again, and it's like a state of boolean of, and that's exactly the thing that the AI is proposing. Okay, here we have a small error. Come here on the top, runtime mutable state of. Press Ctrl and D, duplicate this line, and delete the mutable and delete the off. And we need this import. So now you see that we don't have this error here. We need another variables for the weather and other variables for the scores and like this. Okay, I think let's work on this location materials, then we are going to come back and create these variables. It will be better part by part. We are going to go further and it makes more sense. So function of we are going to create a public function for checking the location permission from outside of the view model, from the UI. So check location permission, and in this we need a value, let's call it context, and equals to get application we don't need this end part, and it's enough. A value has permission equals to context compact, check self permission, and here in the next line we need the context and Android manifest permission access find location. Yes, exactly, and equals to Android context. Let me make it shorter. Context, then in the next line manifest this one, the Android one, dot permission dot. Now here we have the list of the permission that asks. So the first one, the find location, we are going to ask for this permission and close the parentheses, equals to package manager permission granted. Importing this, and then the location permission granted, here we have this variable. The value of it will be equal to has permission. So the has permission can be either false or true. So at the beginning the value of this is false, and if we have the permission it will be true. If we don't have the permission it remains false. So here we are going to check if has permission. If we have the permission granted, we need to check the locations. So let's create a function to get the current location. Then we are going to add this function here. In the body of the view model here, we need a private function. Let's call it get current location. Again, let's check. No, first get current location. I'm going to call it here. Again, let's check if we have the permission or not. So the same as we done here. Let's copy this and paste it inside of this context compact. And instead of this context, get application. Okay, here we checked again the permission, if it's granted or not. So if we had permission, we are going to call the fused location client and get the current location from the fused location. So fused location client, that we build it here. This fused location client, which was equal to fused location provider client. From the location services, we are going to get the location. So fused location client dot get current location. Here we need two parameters, p0 and p1. The p0 is the priority. Dot high accuracy. This one is good for us. And the second one, no. Okay. In the next line, we are going to check if it was the successful or we had failure. So dot add on success listener, and in the next line dot add on failure listener. What to do here? If it was successful, we are going to send data, the latitude and the longitude, I mean, to another function to fetch the weather data. So we should build that function here and add it here. And if we have failure, we are going to have exception, and we need to pass this exception to the UI to show it to the user. So for the data like this that we are going to forward to the UI, we need to have a variable to control the state. I don't want to create here like tons of variables. That's why we are going to create here a data class. If you have watched the movie application playlist in my channel, you are familiar with this approach. I used it there. I recommend you to use it always when you have the view model. I need three variables here. Let me add them. Is loading, which is a boolean, at the beginning is false. So whenever we have like is loading condition, we are passing a request to API or something and we are waiting for the response. This is loading should be true, and later we can check this variable. If it's true, we are going to display like progress bar to the user. The weather data will sit inside it, and the error is using for the error handling. So here in this case, I'm going to use this error variable to pass this exception to it, and later in the UI, we are going to use it. So now we have this weather state on the top. Again, we are going to create a variable to use this weather state. Inside in the weather, private value of underscore weather state is mutable state of weather state. Yeah, you can use this, and a state of weather state. Yeah, we can use it. Now it's ready to use. Okay, here down below in the failure, I'm going to use this underscore weather state dot value equals to underscore weather state dot value dot copy. We are going to edit a copy of this variable and paste it in itself. Why we are using this? We have three variables. Consider we need to change only one of them, and we have data in this and this, and we don't want to change this data loading in this and this. So by copying and changing this variable, these two variables will stay unchanged. Let's check here. Is loading should be equal to false. So in this case, we have error when this on failure listener is called. So already we have received a data, either successfully or a failure. So no need to show the progress bar to the user anymore. And after that, the error can be like this, or we can show a custom message to the user. Failed to get location, for example, and the exception will be like that. Control Alt and L to line up everything, and that's it. It's here, and we have created the weather state and we used it. Now we need to fetch the data. I mean the weather data. So let's create this function, and later we are going to call it there. So we need a private function again. Let's call it fetch weather data, and here I'm going to call this fetch weather data. We need to pass latitude and longitude to this. So let's check. If we have successfully received the location, here in this block we are going to have a location. So out of this location, let me describe the type of it, and a question mark to check the null. And the location, this version. And down below again, let's check it. If we have a location, question mark again, dot let, and inside the let, I'm going to call this function. So if we have a location, call this function and pass the it dot latitude and longitude to this function. Add parameters, and you can see here that we have added the latitude and longitude. Now we can fetch the data. So first of all, we need to change the state of this weather. We are going to launch the network request. So the is loading should be true. Let's start with this underscore weather state dot value should be equal to itself dot value dot copy, and the is loading should be true, and the error should be null, because still we didn't receive any error, any response or any error, nothing. After this we are going to yes, call the coroutine ViewModel scope launch, and then we are going to call this get weather forecast use case. We had it here on the top, this one, and we are going to pass the latitude and longitude which received from the location service, and we are waiting for the data. Let's go to this class and see what we had. Here we had the repository.get weather forecast. We passed this latitude and longitude to this, and through this get weather forecast function, we are going to receive the data, and we are going to pass it into this weather response data class, which has these items inside it, and the type will be a result. We have result here, so we can have on success and on failure here as well. Let's start with dot on success, and below this dot on failure. We can start from the failure again, exception, and in this case the same as we have done here. So when we have failure, we can copy this and paste it here. Is loading will be false. Fail to get this time weather. Weather data. And if it's successful, we need to process the data. Okay, let's create a value here. Let's call it daily forecast. Daily forecast, because it's like the summation of all of the received data, the like 40 items that I was talking about it. Here we are going to have a response, and we need this kind of function to pass this response to it to process the forecast to a daily. What does it mean? I told you we are going to receive 8 items for each day, and we are going to combine all of them to receive an average value of each factor. So everything will be done in this function that we are going to create it here in a while. And finally, the received data, which will sit in this variable, should be passed to the calculate bike riding score. Here in the next line, we need a value again. Let's call it a score equals to daily forecast dot map, and it will give us a forecast, and here forecast to calculate bike riding score, and that's it, whatever we need here in this block. And we need to update this state. We are going to come back to this in a while. Let's create this function here. Inside of the body of this view model, yeah, we need this function. We had such data class at the beginning of the video I showed you. We had the date, the temperature, the weather, humidity, wind speed, and the chance of rain. All of the factors that we need, and especially the date. Here we need to do our process. First, the response will be passed to this class. Then we need to create a variable. Let's call it daily forecast, mutable state of daily forecast. It will be a list out of these single days. So we are going to have either 5 or 6 days. Each day is a daily forecast, and the summation of all of them will be daily forecasts. Okay. You can add here maybe all daily forecasts to make it more clear for you. And we need another value here. To specify date format. Okay, we have a pattern here, and we are going to format all of the dates like this, and then we can do the process of comparing the days to divide the 40 items that we are receiving based on the date. So each item that has similar dates will be in 1 day. It's about 1 day. It's regarding to 1 day. Now we need another variable. This is the thing that I told you exactly. We are going to convert the data, the date, I mean, to milliseconds. And the format of date was like this, and after this, it will be something like this. So we are going to compare this, for example, 4 digits at the beginning, and later we know the items that has this kind of number or belong to a single day, and based on that we are going to divide them. Then the final record after this will sit in this daily group, and we are going to use the values of this list to have the average data. So daily group dot values dot for each. As you see, it's a list. So for each item of this list is containing a minimum 1 item, maximum 8 items of those weather data that I told you at the beginning of the video, and out of these items we are going to extract an average. So a day, or maybe a single forecast. If it's not empty, we are going to do our calculation. So we need a value, let's call it first forecast, the single day forecast dot first, then value max temp equal to single day forecast dot max of dot main max temp. Then for the minimum the same, then a value for the AVG humidity equals to single day forecast sum of it main humidity. No, it's not like this. Single day forecast dot map and it dot main dot humidity dot average dot to integer, because it should be in percentage. Wind speed and chance of rain, like this. Now we have all of the average data in these variables. We need to combine all of them and pass it finally to this daily forecast data class at the end. So let's continue. We had if condition. If there is not empty variable, we are going to have this, and after that we need a value of most common weather equals to flat map of the weather, the main data of it, and the size of it, and question mark dot value of it, question mark dot first and question mark first forecast the weather first. Okay, the most common weather. Why do we need it? Consider in a day, in the morning we have rain, but in the afternoon and after like 2 hours maybe till the end of the day we have like a calm weather condition. So the most common will be clear sky, let's say, or maybe it's sunny but the whole day is windy, so we cannot consider it like as the clear sky. That's why we are going to use the most common weather. Here we had the temperature, the humidity, the wind speed, and the chance of rain. These are numbers. We can make them average or minimum and maximum for each of them. But for the weather condition, which was this factor and is important for us and is not number to calculate it, we are going to use this approach to have the most common weather type in one day, a full day I mean. Then we need another variable to have the daily forecast finally, which is equal to the data class daily forecast, and we are going to load the calculated data inside this daily forecast data class to use it later. So the date, which should be a long number, is first forecast dot date. Then the temperature itself has some other factors. Specify all of the remain data. Okay, in the temperature we need to pass the day. Let me mention the data class. Okay, now we have the day, which is a double. So first forecast dot main dot temperature, then minimum, maximum, and night. Yeah, exactly like this. For the weather, a list of most common weather. For the humidity, the average humidity. For the wind speed, average of wind speed, and till the end we are going to pass all of the calculated data here. Let me have a space here, and that's it. Let me have this comment here for you as a reference. Okay, after that, here after this parenthesis, we are going to use the daily forecasts. This one, all daily forecasts, all of them, dot add the daily forecast. This daily forecast, which is here, is going to be passed to this all daily forecast, which was a list. So item by item. Now we divided our 40 items to either 6 or 5 days, and will be like 6 or 5 items, and you are going to pass it to this variable and you are going to use it. And now here return you can either leave it without this or like this. And if you are going to use another weather API that gives you like more than 5 days, or maybe you are going to use the paid version, so here you can tell that max, I want to do the calculation on 6 days. That's it. Okay. I made a short mistake here. I need to take this and paste it here. It should be here, located in the body of the view model, not in this function. Okay. Now we are done with this. Now here we had this score. We need to create variables on the top for the score here. Then we are going to use it down below. Again, a private value. Let's call it daily scores. Mutable list of mutable state of list of pair of daily forecast of bike riding score, which is empty list, and where you going, and here a value of daily score. Yeah, exactly, this is the thing that I want. Okay, let's go down below in the on success. Here after this we need to call the underscore daily scores dot value will be equal to this score, and the weather state dot value will be equal to a copy of itself is loading false, and weather data will be equal to response. And in this case we don't have any error, so we can pass the null to our error as well. And maybe somewhere else we'll load some data to this weather data variable. So let's have a response dot copy, then the daily will be equal to the daily forecast. It's better now and more safe. Okay, these public variables are on UseCase, and we are going to use them later, like outside of this view model. And we are done here in the view model, nothing else to add. about this. We need just like 2 more functions, but not all related to these 3 parts that I said. But later we need them. Let's have them here. Okay, as you see, we need a function here to get the weather icon URL, just like this. This icon, that one and that one. In each card, we have one of them. And the rest of icons, we build them in the use case. And also, we need another function to format the date. Let's create this one as well, a function for the date. Date, time step, convert to milliseconds, and like this. We need to use these 2 functions later. And that's it here in the view model. We are done. In the dependency injection, we had the view model under construction, and now we can use the view model here. So the view model and get. We need another get here. We had 3 variables there. Application, get weather forecast, use case, and calculate bike riding score use case. And yeah, that's it. All of the things that we need are here. We can pass this here and this here and make it more beautiful. That was whatever I want to tell you about this video, about this part, and in the next part we are going to create the UI together and finally test the application. Till now, the things that you have is enough to see the received data on your application. You can test it by yourself in the UI, just write the text and call the variables in the view model and just check the received data on your UI. And if you want, you can create your own UI based on your imagination and your mind. That was whatever I wanted to tell you. If you have any question, any comment, write them down below in the comment box or in the contact page of my website, and I will be so happy to read and answer them. Give me a thumbs up please for this video, subscribe to the channel, and see you in the next videos. Till that time, happy coding. See you.